in this today's session, here we have to discuss about there is a parallelogram of vector addition. So here we consider there is a two vectors. Say for example, two vectors as P and Q. Consider vector P and vector Q. Vector P and vector Q are the two non-zero vectors. We consider two non-zero vectors. Say for example, the two vectors, say this is vector P and this is the vector Q, are the two vectors which we will be going to consider, and both are inclined. So the angle of inclination between the two vectors is about theta. The angle of inclination between the two vectors is about theta. Acting on a particle, say for example, O be the position of a particle where these two vectors will be acting on a particle. So therefore, it makes an angle over there, theta. Then how do you define a parallelogram of vector addition? For this purpose, we consider there is a two vectors. So therefore, the two vectors are going to be represented as vector P and vector Q. Then, which are drawn from a same point. So you see, this is we call as a same point. From the same point, as they represent the adjacent sides of the parallelogram. So this is the first side of the parallelogram and this is second side of the parallelogram. Adjacent side of the parallelogram, which will be represented by both magnitude as well as the direction. Magnitude as well as the direction. The diagonal. So this O and C is called as a diagonal. The diagonal, which is going to be represents the resultant, which is going to be taken from the same point. Remember, which is taken from the same point and which represents there is a resultant. The same point, the diagonal which will be drawn from the same point, say this is O, and this OC will be called as resultant, and therefore it is the resultant of what? The resultant of two vectors. The resultant of two vectors with both magnitude and direction is called as a parallelogram of vector addition. So this is we call as a parallelogram of vector addition. Now how do we explain this parallelogram of vector addition? Let us consider P and Q are the two vectors. Let us consider that P and Q are the two vectors. Those two vectors are called as a non-zero vectors, and both will be inclined at an angle. P and Q are the two vectors. Two vectors inclined at an angle of theta. At an angle. So how much is the angle between the two vectors? You have theta. Therefore, this will represent which is going to be acting on whom it is theta, acting on a particle, acting on a particle. Therefore, now here to find out the magnitude and the direction. For finding magnitude, that is called resultant of finding the magnitude of resultant. Magnitude of resultant. Yes. Finding the magnitude of the resultant vector. This is OC, magnitude of resultant. So this will be found out. So from the figure you have, from figure what you have? See here, angle BOA, angle BOA is equals to theta, and similarly angle CAN is equals to theta. That's all. Now you find out. Then draw perpendicular, that is produce OA. CN is the perpendicular which is drawn. CN is the perpendicular which is drawn on the produced OA. Therefore, from the figure we got this triangle. Consider the triangle So that is CAN from the triangle CAN, right angle triangle. Then you know that sine theta is equals to sine theta is equals to opposite side divided by hypotenuse. Opposite side by hypotenuse. Opposite what you have CN. Opposite is CN divided by. Then this is we call as a hypotenuse. So this is we call hypotenuse, that is AC. Hypotenuse is AC. Then we can cross multiply. AC sine theta. AC sine theta is equals to CN. Then you know very well. AC is going to be equals to Q. AC is equals to what you get, there is an Q. So this is Q sine theta is equals to CN. Say this is equation 1. Cos theta is equals to. So there is a cos theta is equals to. Cos theta is equals to, we have right. Cos theta is but what? Adjacent side divided by hypotenuse. Therefore, opposite side is what you have CN. And this is AN. AN is the corresponding adjacent side. But how do you write this AN value? For further, we can just remember AN divided by what you write, hypotenuse what you have, this is AC. So this is AC. Therefore, we can write as AC into cos theta is equals to AN. Therefore, this can be written as AC. A to C, once again it is Q. Q cos theta is equals to AN. Then you know very well. From OACD represents what? And a parallelogram. Therefore, from Pythagoras theorem, we have find the corresponding resultant. So this is, so we get there is a OC square is equals to this is ON square plus CN square. Say this is equation number 3, and I write this one as equation number 2. You see here, ON can be written as, ON is the one which is going to be obtained due to OA plus AN. Then you can write this is, implies this equation, OC square is nothing but what? This is resultant. R square is equals to, this is OA plus AN whole square plus CN square. R square is equals to OA. We know the value of OA. OA means nothing but what here? P. OA is nothing but what? We can write the value as a P plus AN. AN already we calculated, that is Q cos theta. Q cos theta whole square plus this is Q sin theta whole square from equation 1 and 2. This is A plus B whole square. So this is resultant. R square is equals to B square plus Q square cos square theta plus this is Q square sin square theta plus 2PQ cos theta, because A square plus B square plus 2AB, and this as it is we kept over here for the sake of understanding purpose. R square is equals to P square plus Q square is common. This is cos square theta plus sin square theta plus 2PQ cos theta. Sin square theta plus cos square theta 1. We can write the value as 1 here. R is equals to P square plus Q square plus 2PQ cos theta. Hence, so this is R is equals to under root of P square plus Q square plus 2PQ cos theta. So this is the corresponding magnitude of the resultant of the given parallelogram. The next one is finding the direction. So there is a resultant. After that, we find the direction of a given vectors. So here we are using, there is an alpha as the corresponding value, and now here divide equation. So dividing the equation here with 1 by 2. Equation 1 by 2, if you divide it, you will get the answer as the one. See, this is q sine theta divided by, this is p plus q cos theta is equals to tan alpha. Therefore, alpha is equals to q sine theta divided by p plus q cos theta into, you can write as the tan of inverse. Alpha is equals to tan inverse of q sine theta divided by p plus q cos theta. So this is the corresponding result. Already we have discussed this one in triangle law of vector addition, which is similar to as that of the parallelogram, and parallelogram is also similar to as that of what, and a triangle law of vector addition. So the both derivations are similar to each other, just the statement and conditions are different over there. And we have a small problem over there. A person having 3 meter displacement, a person having 3 meter displacement, a person having 3 meter displacement towards east and 4 meter displacement towards, and 4 meter displacement towards west, sorry, towards north. In the vector form, displacement vector is, in the vector form displacement vector is 3i cap and 4j cap. That's all. And how much is the corresponding total displacement which is going to be occurred? We know that from the directions, you know very well, this is we call east and this is we call as a west, east and west, and this is we call as a north and this is we call as a south. Then you draw the components. So now here this is we call as a journey which is going to be started by the person. So a man going to be starts his journey at the point O, and from the point O to A is going to be ends his journey along the x-axis, and this is negative x-axis, this is positive y-axis, and this is negative y-axis. And now here he covers certain distance over here to here is about 3, and a unit vector, these are called orthogonal vector. So these are going to be a unit vector which act along this x-axis is called as the 3i cap. And now here there is an again who moves towards an again j cap, that is a 4 meter, and this is 4j cap, and say this is the point A and this is the point B. From A to B he was going to move over there. Then ultimately this is we call as the resultant displacement, that is OB represents what? Resultant displacement of a man. Therefore the resultant displacement of a man can be given as, there is a magnitude, the resultant displacement will be taken as its magnitude, that is nothing but what? So there is a under root of, so this is 3 square, under root of 3 square plus this is 4 square, so this is equals to under root of 3 3s are 9 plus 4 4s are 16, so this is 25, so this is equals to 5 meter is the resultant displacement we get, because the displacement according to the given figure what you find the total resultant. So triangle of vector addition, that is vector OS is equals to vector OA plus vector OB we get there. Then magnitude of this what you write, this is vector S is equals to, this is 3i cap, magnitude and direction 3i cap plus, so this is 4j cap. And then once you remove this magnitude, you will get this answer. How it is seen? So this is modulus of is equals to under root of, this can be written as, so this is x square I cap plus y square of j cap. But remember only this condition, whatever we wrote over here by using this condition here. So therefore tan alpha is equals to, that is the angle it makes over here theta. So tan theta is equals to b by a. B by a can be written as 4 by 3 times of the given value is the answer. 4 by 3 times of the given answer. So next one, laws of vector additions. Here we have the laws we have, there is a laws of vector addition. There are the certain rules or laws will be applied for to study the vector addition. Among the first one is called commutative law, vector addition. So first we call as a vector addition. Among the first one is called commutative law. Commutative law. Always we consider there is a two vectors for commutative law. Here the two vectors which are going to be independently. The two vectors we consider vector P and vector Q are the two independent vectors which will be added together. So hence it is going to be satisfy the perfectly the commutative law. Vector P plus vector Q is equals to vector Q plus vector P. This is called as a hence commutative law will be completely satisfied in addition. Commutative law will be completely satisfied in addition. Then second one, distributive law. In distributive law is also addition of two vector. In the distributive law is also satisfied. How it is? See, we consider there is a P and Q are the two vector. So this is vector P plus vector Q, and the resultant will be taken as vector R is equals to. And similarly, so vector P plus vector, this is vector P plus vector Q plus vector R is the one it satisfies there is a distributive law. This is we call as the distributive law here, and it is also satisfied. The third one, so third is called associative law. Third is called associative law. In the associative law, if I consider K1, K2 and K are the scalar quantities, the K1, K2, or you can consider anyone else. Say for example, K comma K1 and K2 are the scalar quantities. scalar quantities, then you can see there is a vector P into bracket K1 plus K2 gives you what? This is vector P into K1 plus vector P into K2. Hence, it also satisfies the associative law. It is called as what? An associative law. Hence, in addition of two vectors, addition of two vectors completely satisfy the three important laws. The one is called commutative law, second is called distributive law, third is called associative law. And once it will satisfy this all three laws, then it is called as a perfect vector. Therefore, now we have the second one, that is called law of subtraction of a vector. It is also called a subtraction of two vectors. For a subtraction of a vector, for subtraction of vectors, for subtraction of vector number 1, the commutative law. Here, for subtraction of two vector, the commutative law, vector P minus vector Q does not equals to vector P minus vector Q does not equals to vector Q minus vector P. It does not going to be equals, but it is equal. When it is equal, but it is equal when you can take the modulus of this value is always equals to like this. So when it is equal, if I take the modulus over here, if I take the modulus, then only it will be equal. Hence, it does not going to be satisfied the commutative law. Commutative law, the commutative law only goods in what? It holds good in addition, but it does not going to be holds in vector subtraction. It does not going to be satisfied. Second one, that is distributive law. Distributive law. In distributive law, the subtraction of two vectors, in the subtraction of two vectors, the distributive law also does not going to be satisfied. That is vector P minus vector Q minus vector R is not equals to vector P minus vector Q minus vector R. It does not going to be holds good for this condition. Hence, commutative law and distributive law does not going to be obeyed in subtraction of two vector. But here you see commutative law and distributive law will be completely satisfied in vectors. Then third one, here we have the third one is called associative law. Associative law. The associative law which is going to be completely satisfied. It means the associative law but one more condition, remember, for the distributive law, you can just find out there is an, for distributive law, we can write one more condition for the distributive law there. If I multiply the given value with the m into vector P minus vector Q is equals to, then we get there is an m into vector P minus m into vector Q. It means under this condition it will be obeyed. But in this condition, there is a distributive law does not going to be obeyed. It means commutative law, distributive law, associative law is maximum in all the cases will be completely accepted in addition. But whereas subtraction, there is a distributive law and distributive law as well as the corresponding commutative law does not going to be obeyed. and we have one numerical over there on the basis here. The resultant of two forces, the resultant of two forces, the resultant of two forces whose magnitudes are in the ratio, whose magnitudes are in the ratio, our magnitudes are in the ratio 3:5 is 28 Newton. 28 Newton. If the angle between their, if the angle of their inclination is, if the angle of inclination between them is 90 degree. Angle of inclination between them is 90 degree. Find the magnitude of each force. Find the magnitude of each force. That's all. Dear students, such type of problems already we have been solved, and just to try yourself and you can get the answer of this question now. Just to try, because here there is a 3:5 times is given. It means here we consider there is two forces. The one force we consider as a F1 means what we consider 3 times of the x Newton, and the F2 is equals to how much you consider 5 times of x. Therefore, and there is a resultant is also given. The resultant is how much we have. There is an the 28 Newton is the resultant. R is equals to 28 Newton, and theta is given about 90 degree. Then you can substitute similarly. R is equals to under root of, this is p square plus q square plus 2pq times of cos theta. Use this formula, you can get the answer. And here cos 90, you can remember, resultant is 28 Newton is equals to under root of, so this is p square. P square means how much we can write f1 square. F1 square plus F2 square plus 2 times of F1, F2 cos theta. Theta means 90 degree. Cos 90 0. 0 into anything you'll get what? 0. Therefore 28 is equals to under root of F1 is given as 3 square, 3 times of x whole square plus, so this is 5 times of x whole square. 28 is equals to under root of 3 3s are 9 x square plus 5 5s are 25 times of x square. So this is equals to, so 9 square x, 9 x square plus 25 x square. Then this is you get 28. So here you get there is a 34. So this is 25 plus 9. 34 will get, so this is equals to 34 x square, and squaring on both sides you get 28 whole square is equals to, so this is, or you can simplify this, so under root of, so you can write 28 whole square, squaring on both sides you get, so this is under root of 34 whole square, under root of 34 whole square, so this is under root of x square whole square, because we have made a square over there, squaring on both sides for this. Then square and root will be cancelled. This is 28, and if we simplify, we get a corresponding x value, and if you substitute the x value in the given equation, you will get an answer. If you simplify this, you will get a corresponding x value. The x value will be substituted in the given equation. You will get an exact answer for f1 and f2. What is the displacement of a what is the displacement what is the displacement of a point of a wheel point of a wheel initially in contact with the ground when the wheel rolls forward half a revolution rolls over half a revolution. Take the radius of a wheel as r. Take the radius of wheel as capital R. The radius of the wheel taken as capital R, and x-axis as the forward direction, and x-axis as forward direction. According to the question, this is the forward direction we consider along x-axis. This is the wheel we considered. This is the point. So there is a radius is given. So the radius of the wheel is given as capital R. Then, so from the point of contact, remember, from the point of contact, there is this point will be taken, and now if it's going to reach the half of the revolution, so half of the revolution means there is an completely here. So if it is, this is the point you consider as a half, and this will be the distance from here to here is how much you have, pi r, pi times of r it is. The half of the revolution will be considered, and now here this point will be taken. This is B, and you consider this is A, and I will consider this one as a C. And now this point as a center, as a C, we can write as a center as a Y, or you can write any point over there. And now the displacement will be taken along the x-axis, and this makes an angle over there, theta. And from the statement, you can just consider there is a displacement. See, the displacement from here to here. How much is the corresponding displacement? We consider radius as a r and r, and total distance, how much you will consider this one as r, and r will be equals to how much it is, 2 times of the r. So from this vertical displacement will be taken as 2 times of r. Then x equals to, the x displacement is equals to how much you have. So x displacement is equals to pi r, half of the circle. Complete circle means 2 pi r. Half of the circle means pi r. Therefore, you can substitute the total displacement value, x equals to under root of x equals to under root of x square plus y square. So you can consider there is an x square plus y square. X equals to under root of x square means what we have to write, pi r square. So this will be 5 times of r square plus y. Y means what we have to write, total displacement along vertical axis, that is 2 times of r whole square. So x equals to under root of, this is pi square r square plus 4 times of r square. So this is equals to x equals to under root of, so this is pi square plus 4 into r square as a common, x equals to under root of pi square plus 4 into under root of r square, square and root will be cancelled, x equals to under root of r into under root of pi square plus 4 is the right answer, is the displacement. Or the next one. Here we have the next one is called as a polygonal law. After the triangle law or polygonal parallelogram of vector addition, we have the next one is called as a polygonal law. So when many vectors, so more than one vector is going to be taken the same order, and the resultant will be discussed there. And that is what we call as a poly is what many. So many vectors are going to be joined together from the same direction. If I am going to take this, how it will be represented, that will have to be discussed now. Polygonal law. So next one. So there is a polygonal law of vector addition. Polygonal law. So here for the polygonal law, so we have to write the statement for this. If the number of vectors are statement. If the number of vectors are represented by their sides, of a polygon, both in magnitude and direction, both in magnitude and direction, taken in the same order, taken in order. So order not going to be changed, taken in the order. The resultant is represented by resultant is represented by the closing side, by the closing side of the polygon, by the closing side of the polygon, in reverse order, polygon in reverse order, in magnitude and direction. Reverse order in magnitude and direction is called polygonal law. What is a polygonal law? Polygonal law is equal to what? If we consider there is a number of vectors which will be represented their sides only of what it is, the polygon, of the polygonal side it is. and now which will be represented by what its magnitude as well as the direction. The third vector, so there is nothing but what? The resultant vector which will be taken at the closing side, and it is always drawn how it is reverse in order, and that will gives you what? The resultant magnitude and direction of the vector. So this is we call polygonal law of vector. Therefore, now we consider, say this is the first one vector which will be taken from the point here A to B. We consider there is a few vectors. From the one point we considered, say this is A and this is B. This is a vector. Then another vector we consider, say this is C vector. This is a D vector. And this is the one we call A is the one vector which will be taken same order to the second one BC, and C to D is taken as the same direction. And now D to F or D to E will be taken as another vector, and this will be vector will be represented to each sides, and this will be taken the closing side, that is opposite to this. Opposite to this, this is going to be called as what? Polygonal law of vector. Therefore, so we can write this is F1 vector. So this is F2 vector. This is F3 vector, and this is F4 vector, and this is we call as a resultant. We call as the resultant vector. And now we can call, so this is resultant is also nothing but what here, we for the addition of two vectors we can also take in this value, as we can write this one as commonly continuous, we can write as a F5. Therefore, by addition you can take F1 vector plus F2 vector plus F3 vector plus F4 vector plus F5 vector is equals to 0. So this is going to be called as what? An polygonal law of vector addition. Just to remember, only in this case, only the thing to be remember is what? We consider there is a n number of vector, or you can consider the number of vector which will be represented the magnitude and direction. All the vectors will be taken in the same direction. So they will be taken in the same direction, but the resultant will be taken in reverse direction. The resultant will be taken in the reverse direction, and that reverse direction gives you what? And the magnitude and direction of the resultant of the given vectors. Therefore, F1 plus F2 plus F3 plus F4 plus F5 is equals to what? 0. This is we call as a polygonal law of vector addition. So after this, we have there is an important concept which is going to be called as a dot product and cross product of two vectors. Dot product and cross product of two vectors. It is also called as a scalar product and vector product. The important point of this chapter is only the scalar product and the vector product. The key concept of this chapter is only these things. Next one we have there is a scalar product and vector products. Scalar products and vector products. Vector products. Yes. So these are the important key points of the chapter. So now, if you have any doubt, you can ask.